Now we're going to look at some descriptive statistics. In some places you'll see it called univariate statistics, but most people just call it descriptive statistics. This is where we're going to summarize one variable at a time. So we're looking at one variable at a time. These can be used with frequency distributions, relative comparisons, when we look at measures of central tendency and variability. With frequency distributions, we're really looking at how the data is distributed or are distributed. Got to get my grammar correct there. So it's also used to arrange values of a variable and their responses. So here, let's look at a real simple example. What is the frequency distribution of campers' characteristics? So we look at different campers. We've got 4, and then we're looking at age and asthma. So as we look across this, we can, because it's a smaller sample size, right? We can look at it and say, we understand that the frequency distribution of age is from 10, the range is from 10 to 12, with more 10s appearing than other ones. And then we look at the asthma, and we're looking at mild and moderately severe as being the 2 cases here. So overall, we can look at the frequency table and understand a couple of basic things about our sample size. Then we'll move on to relative comparisons. This is how we describe data for a variable compared with each other. So we can look at rate, ratio, proportion, and percentage. Rate is the frequency of occurrence of a particular outcome. So what we do here is we divide the actual number of occurrences by the number of possible occurrences. So let's take an example here. We're going to have 10 people that we ask if they like chocolate milk or not. And 5 of them say they like chocolate milk and 5 do not. So our rate is be 5 out of every 10 people like chocolate milk. Let's look at another example in a little bit more detail. So here we have 97 student athletes, and we're going to say 64 of them are graduating. So what we're trying to do is understand the graduation rate of our student athletes. So since we've got 64 graduating, we'll divide that by the number of student athletes in total. So 64 divided by 97 gets us a number of 0.66. And then we want to multiply it by some kind of base to better understand it or help understand it a little bit. So if we want to say how many, let's just say how many student athletes out of 10 are graduating, we'd multiply that by 10. So we got this 0.66 times 10. And overall, we can say, hey, the graduation rate is 6.6 students out of every 10 students are graduating. And that's how we get the rate. So it's a 6.6 out of every 10. And we got that by dividing 64 divided by 97 gave us a 0.66. And then we multiplied that by base 10, so we could say how many people out of 10 would be able to graduate or are graduating. So let's take the next logical step and look at ratio. And this is the comparison of the frequency of one response with the frequency of another response. So we're comparing 2 responses to each other. So here's an example. The number of people that missed activity therapy due to either not being able to get off work or who simply forgot. So we had 23 who could not get off work, and we had 10 who just forgot. So what we do here is we do the first one, which is 23 divided by 10. So we're looking at who could not get off work versus who simply forgot. So 23 divided by 10 equals 2.3. And what we can say here is we make the next step in interpretation of that data is for every 1 patient who missed sessions because they forgot, 2.3 missed because they could not get off work, right? So if we look at that again, we had 23 who could not get off work and 10 who forgot. So if you look at it that way, you can make some logical steps here. 23 divided by 10 equals 2.3, which makes sense. And then we're saying that for every 1 patient who missed sessions because they forgot, right, 2.3 have missed because they cannot get off work. And if we look back, that makes sense because we had more people that were unable to get off work than forgot. Here we're going to look at proportion and percentage. So a proportion is a ratio to the total, and a percentage is a proportion multiplied by 100. This is used to compare frequency of a response with the total frequency. So here we take the number of actual occurrences and compare it to the number of possibilities. And then we're going to convert the answer from that one into a percentage by multiplying to 100. All right, so let's look at an example of proportion and percentage. Here we have 41 kids that fell from playground equipment. So they fell off playground equipment. And we have 68 kids total who got hurt on the playground. So this includes falling from the equipment, tripping when running, and all kinds of other stuff. So again, we got 68 total kids that got hurt, but 41 specifically got hurt from falls. And what we want to know is what's the rate or percentage of kids that are getting hurt specifically due to falling. So if we look at proportion, the thing we're going to do is I'm going to say 41 kids fell and divided by 68 total, and we get 0.6, right? And then to get the percentage, we're going to multiply that by 100, which gets us 60. And then we can simply say 60% of all the playground injuries were due to kids falling off the playground equipment. So 60% of all injuries on the playground were due to falls.